Hello everyone, I'm Julia. I'm here to present my project. I would like to call it as fraudulence. As the name suggests, it detects fraud, and for particular industry, that is insurance industry, especially for car insurance. Actually, nowadays people are using high super realistic fraud images to get insurance claims. So uh, actually we were living in a world where images are submitted as an evidence for a car accident, but that is no longer the case. We can't rely completely on an image because it is highly generated, it is highly manipulated. So and these all the images can easily bypass the traditional bypass systems. So and let us see what are the impact of the fraud activity in the insurance field. First one is the consumer impact. That is, when a fraud activity increases, when a fraud activity happens, there is a billions of amount of loss to an insurance company. So what will happen is, to compensate this amount, the insurance companies will force to increase the premium. So what happened? Even the genuine customers will force to pay the premium, like larger premium amount. Then one of the second impact is process delays. That is, due to the increase in the fraud activity, the insurance companies will become more conscious. So they will keep multiple checks on this process to check the claim. So there will be a significant delays in the claim process. And as a result, at the end, there is a erosion of trust. The people will lose trust in this entire system. Then these are some of the articles which shows how AI is used or misused to make fake images and to get fraudulent insurance claim. There are existing systems like to find the reliability of an image, but I found that there are some limitations in the current systems. One is physical plausibility. That is, in current system, it only checks the pixel of the image. It's not checking the it's completely avoiding the real world optics. Second is geometrical irregularity. That is, in real world, like of course, a car is made up of metal and it follows a like strict structural pattern. But when AI created a damage, it will not follows these kind of things. I mean, it like sometimes it will be blended or some angular distortion will be there. And third is shadow inconsistency. We can see that in AI generated images, usually there is a problem with the shadow. Sometimes the shadows will not be there, otherwise, there is a problem with the orientation of the shadow. And the last one is digital in fingerprinting. Uh, Current system mainly focus on the exif metadata, which can be easily manipulated or edited. And what I'm trying to do is keeping on mind all these setbacks in the traditional systems. I introduced a two-layer forensic thing into my system. One is physical layer, and second is digital fingerprint layer. In physical layer, it will check the plausibility things. One is lighting consistency, and second is edge, as you can see, edge distribution, and third is shadow ratio. And in the digital fingerprint layer, it will check both metadata and noise uniformity. And this is the brain of my project. It is brain of my fraudulence. It has got three layers. First one is neural layer. This is the part where feature extraction and pattern recognition takes place. Then forensic integrity. This is the part where all the plausibility checks and the digital fingerprints checks take place. And last one is the ensemble decision layer. This is the final verdict layer. This is the part, like this is the layer where the original decision takes place. I mean, it will decision layer will take the input from neural layer and forensic layer, and like it will examine this and will give an output, whether if the image is fake or real. If the image is real, then the company or insured people can proceed with the claim. If it is not real, then it is rejected immediately. Then let's have a look at on the system architecture. First, the input image is fed to the neural layer, and I have used ResNet 50 here. Second, it is a forensic layer. It is for the plausibility check and the, as I told earlier, the fingerprint thing, digital fingerprint things takes place. Then the output from these two layers is fed to the ensemble layer. That is the main part of my project. That is where decision takes place. Here I was using XGBoost. Then like from this, the output will be given. That is the final verdict. The final verdict is like, it is a binary classifier basically. It is fake or real. If it is fake, as I told you earlier, it will move with the claim. And if if it is fake, it is reject the claim. And if it is real, it is move forward with the claim. This was the performance metrics, and I have got about 79.8 value of accuracy. And coming to the dataset overview, I have used two types of dataset. One is original and one is synthetic. Original dataset I have took from CardDD dataset. It is Hugging Face, and for the generated thing, synthetic dataset, I used OpenCV and Nano Banana. I actually tried Stable Diffusion, but I couldn't, generate high quality images because I was using a free version. So the quality of images was really bad. So I had to drop that thing. Then OpenCV, the quality was okay. For that OpenCV, I was like running a Python script, and I was using some technique like slicing, copy paste, blurring, etc. The quality of that image was okay, but from compared to Nano Banana, I used a paid version for that. I spent money, and I'm not happy about that, but it's okay. And it was come really good. The quality was really good, and it was for the money. I'm happy for that. Then let's go to the demo. This is running in Streamlit. Let's upload our image. Let's run the analysis. We have to read, it's a fake image. You can see it is generated with Gemini. The symbol is here. So I think my model is working fine. It's brilliant. And yeah, it checks the plausibility things, lighting asymmetry, noise variance, edge imbalance, and shadow ratio. There is a suspicious level in lighting asymmetry. And is reject the flame. And we can check one more picture. Yeah, it's a real image, and you can approve the claim. It's a safe zone, so just proceed with the claim. And future vision. Now my system is basically a binary classifier. It's just detecting it is fake or real. When moving forward, I really want for like specific object detection. It's like I want my model to detect which part of the car or which vehicle is manipulated, and on what degree it is manipulated, and some behavioral metadata integration as well. Then third one is explainable AI. It's like I would like to add some descriptions so that even a person without much technical knowledge can understand why it is rejected and what's the reason behind that. Then other is multi-vehicle support, and it's like now my model is only specified in car images. So in future, I would like to add some other vehicles like bus, truck, whatever.